In this video, we're gonna evaluate the following double integral. Okay, here our function in this case is y. That means f of x, y is y. So we have a function that depends on two variables, x and y. Okay, and here when dealing with these integrals, we will evaluate the variable with respect to y first. Okay, and we're gonna keep x constant for now. Okay, so we know how to do that. Here we keep x between 1 and 2 and we integrate y. So we know that y squared over 2 is the primitive of y. So we're gonna evaluate that between 1 and x. Okay, and after that we're gonna integrate with respect to x. Okay, once we evaluate, we have x squared over 2 minus 1/2 dx, and we know this one here. So this is something that we know. So we take the 1/2 outside and we integrate x squared minus 1 between 1 and 2. Once we do that, we know the primitive of that is x cubed over 3 minus x between 1 and 2. So once we do the evaluation, we will get 4 over 3. That means 2/3. This means that our integral is equal to 2 over 3. It's always good to graph the domain or the region that we are integrating on. Okay, here x is between 1 and 2 and y is between 1 and x. Okay, let's graph that. Okay, so we have x is between 1 and 2, and we have this function y is equal x. We know that this is the one here, so this is y equals x, and y is between 1 and x. Okay, so here but y is always between this value here, between y equals 1 and y equals x, and x is the maximum value that x can get is 2. So we are here in this region. Okay, so that means when we fix x between 1 and 2 and we let y change, okay, we let y change, it's gonna change between 1 and x. Okay, so this is the first it's always good to draw these regions because we can switch this integral and we can instead of integrating first with respect to y, we can integrate first with respect to x. It's always good to know this two. Okay, because sometimes it's very difficult to evaluate with respect to y. We will see that. We'll come back to that. But this is it's always good to draw the region that we are integrating on. Okay, thank you very much.